pipe sizing for a given flow rate, pipe length, and heat loss by using Darcy-Weisbach equation and modified Colebrook's equation. So in this case, we're using modified Colebrook's equation. Now the way to do it, we will assume an initial value of friction factor. We use that initial value of friction factor to calculate the diameter for. We use that value, the assumed value, calculate the diameter. Now we plug the diameter into the Darcy-Weisbach equation, which is this. Now making D the subject of formula, we have D as this. So if we plug it into this place, we'll now solve for D. I haven't gotten the value for D. We'll now use that value to get our Reynolds number. Now we now use haven't gotten the Reynolds number, the diameter. Then we find the new friction factor using the modified Colebrook's equation. Now we compare the value of the new friction factor and that of the old friction factor. If the value is more than this, we continue with the loop till they get to the point where the difference is less than this. Then you will now know that yes, the solution, that should be the solution. So what we're going to do is, this is the modified friction factor. Now this is the modified friction factor. Let me use the snapping tool to copy it. Let me say edit copy. I'll open this. Open a new tab. Hide the page title. Now, what I'll do is to paste what I've copied. Move it up a little. Now, so what we'll have is F is equal to minus 4 log 10 log base 10 E divided by 3.7D plus 1.4125 bracket open F all over R bracket close. So to make this thing similar to 1 all over this, this one is transmission factor, while this is friction factor, while the small f is friction factor. So now we want to make it to look like that of the Colebrook-White equation, not the modified one. The Colebrook-White equation is written like this. It's similar here. There are different values here. You have 2, 5, 1 here. Divide by r square root of x. So now we need to make this. Now to write this in terms of this, let's say this, let me call this equation 1. This one is equation 2.
Why was you crying?
Now if you divide this to this, you have f all over 4, which is equal to minus log e all over 3.7d plus 1.4125 f over r bracket close. This is equation 3 now. Now this one can also be written like this. You see, this one dividing, this one you're using, you say dividing both sides by 4. Now this one, for you to make this equal to just the same as this, as minus log, so you say dividing this one, dividing, this is equation 1, dividing equation 1, dividing this one, you say dividing equation 2, dividing equation 2 by 2. Now you have 1 all over 2 square root of f equal to minus log base 10 e all over 3.7d plus 2.51 and square root of f. So now comparing this point and this point, now you see you have minus log here, you have minus log, so comparing these two, you have f all over 4 equal to 1 all over 2 root f. Now you will have f equal to 2. Now if you multiply both sides, if you multiply the left hand side and the right hand side with 4 by 4, we multiply them by 4, you have f, capital F equal to 2 all over square root of f. So if you substitute f equal to 2 all over square root of f into equation 1, which is the modified, into equation 1, which is the modified Colebrook equation, you now have 2 all over square root of f equal to minus 4 log base 10 e 3.7d plus 1.4125 times 2 all over Reynolds number times root 5. Now if you divide both sides dividing both sides. Sorry, both sides. Dividing both sides by 2. You now have 1 all over square root of f minus 2 log 10 p divided by 3.7d plus these 2 times this. We give you 0.52 8.2 all over r square root of f. Divided by r square r times square root of f. Now, the difference between this modified Colebrook's equation is just this. In Colebrook's equation, you have 2.51. In this one, you have 2.8250. So that is the difference. So that means the only thing we're going to change in Colebrook's equation is just this value. Now, so the pipe sizing we did using Colebrook's equation, what we're going to do is we'll copy the same thing. We only change this value here. So let's go there and make those changes. So let me open this. Open this. So what we're going to do is we insert a form. We call the form FRM pipe sizing modified Colebrook. Enter. Now I'll just expand this. What I will do, let me look at the pipe sizing. Look at the properties, the height. The height is the width is 16 to 30. The height is what? 10 to 4, 5. Was 10 to 4, 5. So let's go to this one I created now. So I will change the height to, okay, the width is 16 to 30. Make it the same. The height is 10 to 4, 5. The height is 10 to 4, 5. Now I'm going to add a frame. Okay, now before I add a frame, let me change the font. Let me modify the font. Now I will use Time New Roman. Time New Roman bold 16. Now I'll change it. I'll change the back color. Hmm? Okay, I'm coming. I'll change the back color to blue. Now let me paste this. Let me attach this frame. I'll change the back color of the frame to blue. We did this. I'll call it the caption. I'll call it. I'll say is pipe. Call it pipe sizing. Pipe sizing using modified Colebrooks. Now let me go to the pipe. Look at this. Let me select that. Let me look at the equation. Let me look at the size here. We have 17.415. What will this be? It will be less than that. I have what? 16. Let me see. 10.81. 17.415. Let me see. Okay, the weight is 24 and 13,500. 24. So the weight is 24. This is 24,000. The height is starting 500. Let me be sure. 13,500. So this other one. This should be 10.8, 10.815, 17.415, 17.415. So then 815. 17.415. 17.415. Let me see. Let me be sure. Seventeen 415. 10.81. 10.815. Let me see. 10. 10.815. We'll go there. Since everything is the same, we'll just come here, I'll copy the whole of this. We'll just copy this, select this, select this, select this, then copy, go to this, open, paste. Just move this way a little down. So it's okay. It's okay like this. Okay. Okay. Let me just adjust this a little. No, I can change this up here. The caption on the phone. Let me just change this to seal pipe sizing. Using modified Colebrook's question. Now, so I'll go to this, copy the whole of this. Copy, go into this form, go into the pipe sizing modified Colebrook's equation form. Go into the code environment, paste that value there. Paste what you copied there. Then we needed to change this. We need to change the object name to modified, using modified. So we also need to change this too, using this modified. Select this modified. So we are done with that. Then let's go down. Okay, there's nothing to edit again. Now let's also, we now need to open this. Right click, select this menu editor. You can also get the menu editor from here. Let me remove from the tools. You go to the tools, you select menu editor, or you say Control E. You press Control plus E. The menu editor will come up. So let's do this way. Do it this way. Menu editor. Now we needed to add something here, so I will just say insert. Now I will index twice, then I will just name it. I will say using modified Colebrook's equation. Now we need to complete this because there is no name, so we call it modified Colebrook's. Let's say okay. Look at it here. We need to click here. Okay, it's there. So for modify, so it's there. So now so let me check if let me change this to this. Paste. Undo. Select this, press tab key. It's okay. Now let's check if it will work. Select this, select the pipe size, and select this. Okay, it works using modify Colebrook equation. Okay, let me exit. Now let's look at the form again. Do this. Okay, this we need to change it. Select this, press the tab key. Solver. We need to also change this. Okay, there's nothing to change here. Let me see. Now let's go to. Now we need to create another module for this. So we'll just right click, say add module. Now change the name. The name should be modified Colebrook. Modified Colebrook. So now I will pipe. That's modified Colebrook. So pipe sizing. Just say pipe sizing. Pipe sizing modified Colebrook equation. So where is this? Open this. Copy the whole of this. Copy. Go to this. Pipe size modified. Paste it here. Now change. Okay, I need to change this. Change it to pipe size modified Colebrook. Now we need to copy this and replace it here. Let me see this place. I will replace it here. That is what they will call. Now you call this. Now when you press the solver, it will call that. So let me save. We go to this. We go to my external drive. We go to external drive and maybe save here. Yes. I modified this form. Let me save again. Okay, let me just save with this. No. So let me open this. I need to change this. Okay, change. I also need to change this. I need to change the form name, the name of the form, to this, to the modified Colebrook form. Now, so we have, let me open this form. So now I need to create the class. So just right click here, go to add class module, press open, change the name to CLS pipe sizing modified Colebrooks. Modified Colebrook. So pipe sizing modified Colebrook. So I haven't done this. I will go to this place, copy the whole of this, copy all of them. The only difference is what I will make the change for. So I will open this, come here, paste, Ctrl V, paste. So the only changes I will do now is I will come here, make change. I can leave that because it's only here. I will come here, make changes to the form, change this. I will now come down here. Now I needed to change this to, instead of 2.51, to change this to 8. Is it 81? Let me see, 8250. Let me check it. Let me check. 2.8250. So that is it. So I'll just copy. I'll copy this. Copy. Now I'll just change the whole of this to that value. Okay, let me just copy only this part I changed. Copy. So I'll just paste. Is there any other place I needed to add them? Okay, here, paste. Is there any other place? Okay, let me be sure I've made all the necessary changes. Let me be sure I made all the necessary changes. So okay, I've made all the necessary changes I needed to make here. So I'll save this too. 6. Now let me go to the module and change the class, because I've created a new class, which is this. There is a tab key. I also created a new class, so select this. Now the whole of these are just the same thing, so I don't need to change any other thing there. So what I'll do now next is to open the problem. Let's test what we did to see if there is any bug in the program. Then we'll make corrections. Let me open this. Open one of the questions that was solved. Like I pause it. It's like I'll pause it since the thing is delaying. So let's open this. So this is a problem. This is pipe sizing that I used Excel to. And I use Excel to solve. So I want to run it here to see if what I got, the output here, is the same thing with what. So these are the input. These are the given values. So let's check now. Let's run this. Let me run it. Let me just minimize this. Shift this thing one corner. Oh, I have the kinematic viscosity to be 0.88. The flow rate is 4,000 barrel per hour. So to change it to barrel per day, we multiply by 24. We multiply 4,000 by 24, we have 96,000. The specific gravity is 0.763. The absolute pipe roughness is 0.002. The pipe length is 5,000. The pressure drop is 27.24. So let's run it to see if there is any bug or anything, so that we make corrections. Okay, there is no error here, so the thing runs. So what we got, let's see the outputs for this. Let's see the output. So let's compare the output. So we have friction factor 0.0145. Here is 0.0144. We have internal diameter 14.54 here, while from Excel we have 14.54. The Reynolds number is 692,334. In Excel we have 693,799. Then the flow velocity is 5.41 here. In Excel 5.43. The pressure drop is 8.68, while in Excel is 8.69. So the modified friction factor. It's okay. Now let me also compare the results with solving this using using Colebrook's white equation. This is using modified Colebrook. Now using Colebrook's, we have here to be 0.88. Here is 96,000. Here is 0.736. Here is 0.002. Length is 5,000. The pressure drop is 27.24 feet. So when you solve, you have this. Let me open that one for modify. Now this friction factor is 0.0144, which is correct. Reynolds number is 0.693840. Different from this is 5.43. This is 5.41. The pressure is, the internal diameter is 14.51. Here is 14.54. This one is the same. So that is done. So let me exit. So, and let me close. Let me stop here. Thank you for watching. In my next video, I will explain using MathCAD. Now, thank you for watching till the end. Please subscribe to my channel if you like the video and hit the notification bell. Thank you.